Hello, CDCon community. My name is Andy Grabner. I am recording this from Linz, Austria, where I'm from. I'm going to talk about a guide to event-driven SRE-inspired DevOps. I know this is a lot of buzzwords in a single title, but hopefully you will see that we're actually really trying to solve a problem here. Who are we? Well, I am representing Captain, a cloud-native sandbox project, a CNCF sandbox project. Captain, as you can see on the bottom, spelled K-E-P-T-N. If you're interested more after this talk to learn about Captain, to contribute, to try it out, you'll see how you can follow us, how you can star us, how you can join the Slack channel and so on. In my day job, I also work at Dynatrace, but today this is really focused on Captain and how we want to change the way we do traditional delivery and also operations. All right, let's get started. So what a lot of us are asked to deliver is a modern cloud-native progressive delivery and operations workflow. So what that means, if you have a 3-stage pipeline like I have here, and you have build number 3 deployed, if you are a developer, you want to have an experience where you do a pull request, that build is then deployed and tested in dev, then you evaluate against your SLOs, some quality criteria, and depending on how that goes, hopefully everything is good, it gets promoted into the next stage. Same thing, the pipeline should deploy and test, because you run probably more tests, you want to evaluate against your SLOs, you want to make sure everything is good, and then, depending on your organization, you may not want to automatically promote, but you want to get the chance to say, let's pull this new build that made it through staging into prod, where then you most likely want to do something like a blue-green deployment or a canary deployment, then evaluate again after you deploy it, and in case something failed, right? Because sometimes things that work in staging may not work in production under real load. Then you want the delivery pipeline to automatically push it back, like toggle the blue-green, but then obviously always evaluate if that toggle switch back actually succeeded, because if not, then obviously you have to interact anyway. But this is kind of a way how we can increase speed and quality through a lot of automation in progressive delivery. Now, on the operations side, right, if things run in production, then we want to integrate with your monitoring and alerting tools. So if there is a problem, then we want to react on it. So for instance, there's a failure rate increase, maybe as an automated action, we want to scale up. Most important is though, every time we execute an action, we want to evaluate. We want to make sure that the system actually is back to its healthy state or its intended state by looking at the SLOs. In case the SLOs are not where we are, maybe we can execute another action, fully automated. And the most important thing here is every time we execute an action, we want to evaluate if this action actually solved the problem. If none of these actions is doing something good, then obviously we can escalate. But in the end, this is kind of the process, what we call automated operations. Some call it self-healing, pick whatever fancy term you like. But this is the world we live in, that things are asked from us to deliver to our organizations. However, in reality, what we have seen, only a very small number of organizations is actually there. And I didn't come up with these numbers. We actually did a survey. We also work with our Captain open source community. And this is also why in Captain, we want to address the root causes, at least 3 problems that we have seen people struggling with. And this is time wasted in maintaining traditional pipelines, then time spent in manual tasks along the pipeline, and then also in operations, time spent in manual remediation. And these are the 3 things I want to focus on in the next 15 minutes or so, and show you how Captain addresses these problems. All right, so first one is we're spending a lot of time in maintaining monolithic pipelines. So what that means, this is a screenshot of one of our Jenkins pipelines we actually have internally. It's not that big, but 350 lines is already reasonable size. But the problem is not the size. The problem is, in a classical pipeline, you have a mixture of process definition and target platform. So where do you deploy into, what type of tools you have, everything is really hard coded into this particular pipeline definition, whether this is Jenkins or other tools. And so there's really no clear separation of concerns on how to define the process, how to define the tooling, and how the developer can actually properly use it without having to mess things up. The problem is not only these pipelines that are hard-coded, but a lot of the time, you start with a pipeline that looks good for one project, then you take it, apply it to other projects with some slight modifications, and then more and more people are using it, and then you have this classical snowflake effect where you have an initial original source of code, and then it got modified slightly, and then if something breaks, you don't really know anymore why does it break, who brought in this plugin, what is this thing doing, and then it's really hard to keep this pipelines running again. And this is also why we're spending so much time in keeping the pipelines running, because they break a lot. So we want to solve this problem through an event-driven approach. We want to give you back the time, because I think engineers should not focus on fixing pipelines constantly. So how do we do this? The solution is actually really simple, is we are breaking apart the dependencies between your process definition and your tooling. So that means if you have on the left side your classical, build pipeline process or your delivery process, and on the right side the actions that you do, instead of hard coding them, we rip it apart. And just as in modern software architecture, where you're building event-driven systems, you basically use eventing to then tell the tools that they should do a particular job as part of your workflow. So you have on the left side a workflow orchestrator that takes care of the workflow and is then triggering events to then actually trigger the right actions. So the idea is, if we need to deploy, let's say, container 1 in a blue-green fashion in dev, then the event is sent out, and a tool that is registering these events can say, yes, I can do this, so let me deploy, and when I'm done, I'm sending back the event that I'm done. And then the workflow engine or the orchestrator can then say, okay, the next thing after deployment might be testing, and then it's then sending a test event. But this is a clear separation of concerns: process definition, tooling, and then in the middle we use eventing to connect the whole thing. And I think this is not a magic ingredient, but it's an ingredient that we want to apply to continuous delivery and automating operations. And this is where Captain comes in. So the way Captain works, Captain, as I said, is a CNCF sandbox project. You install it on any Kubernetes flavor. What you really get is a control plane that is managing the flow of the processes, the application flow, and is using eventing to then connect with the tools. For eventing, we're actually using Nets and some other open source projects, but this is kind of the control plane. We have an API, how you can interact with it. We also have a UI, which you will see later in the demo. Now on the top, we are allowing, let's say, site reliability engineers or whoever that is in your organizations to define the application plan or the process. We call it the shipyard file, as you can see on the right, where you specify which stages you have: dev, staging, prod, what type of deployment strategy you want to apply, and also what type of test strategy you want to apply. So this is the process definition. Then you may have another team, let's say the DevOps team, maybe it's your tooling team or your pipeline team. They can define which tools to be used. So this is what we call the uniform, where you say, I have these tools and they are registering for these types of events, because let's say you want to use Helm for deployment, you want to use JMeter for testing, you want to use Prometheus for monitoring. Then you can install these tools that are just listening for these events as the Captain control plane is executing the workflow. Now, the beneficiary of all of this is the developer. So if the developer has a new artifact, makes a pull request, and triggers a Captain workflow, then Captain is sending exactly these events to then trigger the tools that are registered to handle these events, and is therefore pushing an artifact through deployment, testing, validation, promotion. And also in operations. So this is now more focused here on the delivery process, but we also have the process for operations. If a problem comes in from your monitoring alerting tool, Captain will also orchestrate a workflow of evaluating the problem, executing an action, and validating if the action succeeded, and then does this in a repetitive way. This is the architecture of Captain. The benefit here is we have a separation of concerns. One side can change the process at any time without impacting the tooling, and the other side can also change the tooling at any point in time without impacting the process definition. There's no, let's say, big monolithic pipeline anymore where everything is hard-coded. Now, let me go to my first demo. I do have a 3-stage pipeline. As I said earlier, I have my sample app in 4 versions available. Every version has slightly different problems built in. And in order to kick off the build or the deployment of version number 4, I just say Captain send event new artifact. And then what Captain does in its event-driven fashion, it first makes updates to the Git repo. So in my case, it updates my Helm charts with the new version. It then does a Helm deployment. It then does a JMeter execution, and then the quality gates get executed. I've specified that I have automated approval into staging, which means if it's good, the quality gate, it goes into staging. The same step happens. quality gate is enforced at the end. Then I specified manual approval because I don't want everything to go into prod. If it's a good build, then I get the choice to say yes or no. This is where you can say promote or not, as you can see on the right. And if that happens, same thing works, same process happens, gits change. In this case, I'm doing a blue-green deployment, then I'm running some more tests, and then the quality gate will be enforced again to then validate, do we want to keep it or do we want to roll it back? All right, so let's go over. This is the process definition that I have in my Captain instance. You can see here exactly what I said earlier. We call this the shipyard. I have my dev stage, I have my staging, and I have my prod with the different deployment strategies, test strategies, and approval strategies. In production, I also have a remediation strategy, which is a use case I'm showing later. And in order to kick things off, I only have to do Captain, send event, new artifact. Captain is organized in projects. A project can have multiple services, and then you give it a container, and that's it. I kicked this off earlier, so let me go over. So what I have here is my Captain's bridge. This is the UI, and you can see here, yesterday I did a build number 3 in the evening. This is the build number 4 that I did this morning when I did the recording. And you can see here the full chain of events. So Captain is sending these events and is therefore triggering the right tools. So for instance, it deployed build number 4 in dev. This is my build number 4, right? Looks strange with the way there's not a whole lot to it, to the app, but it brings a point across. Then the tests are executed. I didn't specify extra SLOs, which means depending on the test result, it does go or no go. Then it went into staging. It deployed into staging. Let's also open this one up. Build number 4 in staging. That's great. Then more tests got executed. I actually have some peak performance tests here with JMeter. And then one of the magic ingredients comes in. This is the SLO validation. So in my case, Captain reaches out to my monitoring tool and pulls in defined metrics that I have, and then is evaluating it, and then it's giving me a result. And I got 100 out of 100 points, which is great, which means it's now ready to promote it into production. I can either select it here to say go, or I can also go to the environment overview where I can see I've build number 4 in dev, build number 4 in staging. In prod, I've still build number 3, but build number 4 will be available because we achieved 100%. So in this case, I let it go. And now Captain is going to continue that workflow. So if I go back here, right, it's now continuing that workflow, which means first the configuration change, then the deployment, then the testing, and then either keeping it or rolling it back, because this is a blue-green deployment. So this is kind of the first use case. We also have users that are integrating Captain with their existing CI. So Patrick, they're using GitLab CI to build containers. That means once the container is built and pushed to the registry, then they're calling Captain, the whole CD workflow through the Captain API to then do multi-stage deployment with the quality gates, with the testing and the integration into monitoring. All right, so this was the first problem that I wanted to address. The second thing is a lot of time in pipelines, in traditional pipelines, is spent in manual deployment validation. What we've seen is, I assume you have a lot of you have pipelines, whatever pipelines you have, where you do build, test, and deploy, and then you run some tests. And then typically a lot of time is spent, as we have seen, with manual approvals. Why is that? Well, because if you have a functional test automation, it's sometimes hard to say, this functional test failed, but is this really a feature that is actually critical for us for the business? You know, why do these questions come up? Because I think a lot of organizations still haven't really specified good SLIs and SLOs. So what is really important? Also, if you include performance testing, it's really hard to look at all these metrics, and sometimes you're overwhelmed to say, is this better or worse? And a lot of organizations are now also including monitoring data, which means even more data. And so it's sometimes hard to really make a decision. This is why things take that long. And this is why we wanted to solve this issue by automating the approval through an SLI and SLO based approach. Now, if you're new to SLIs and SLOs, we didn't come up with it. I think Google didn't come up with it, even though they brought it to the world with some fancier terms. But essentially, this is part of their SRE practices, their site reliability engineering practices. They talk about SLIs. So these are simple metrics, so something you can measure, like the error rate of login. Then your SLOs, your objectives. So what do you expect that metric to be? Let's say error rate of login should be less than 2% over a 30-day period. Right? That's a clear objective. And then you have your classical SLAs, which are basically SLOs, but where you actually have a legal binding contract. So basically, what happens if you don't meet your SLOs? Then maybe you get punished by your customers, or you have some legal obligations. So there's a great video from Google, and also in general, I took this basically from Google. They did a really great job in advocating this. Now, what Google talks about and what the world talks about is using SLOs in production. So your monitoring tool of choice, I'm pretty sure, can monitor, report, and alert on SLOs on a service basis, on an application basis. Every month you get your SLOs based on your metrics, whether this is throughput, error rate, or response time, or any other metric. But we thought, why not shift this left? Why not take the same concept, a metric against a threshold over a period of time, and do it as part of delivery? And that's what Captain Quality Gate does. So every time you push an artifact through the pipeline, after the tests get executed, we automatically reach out to your monitoring tools or to your testing tools or any type of tool, pull in metrics, compare them either against the threshold that is specified or against previous builds for regression detection, and then tell you good or no good. All right, now this brings me to the next demo. I want to show you how this works with Captain. I'm using Dynatrace as an example, but you can do the same thing with Prometheus or any other monitoring tool, because Captain is open, so it can pull data from any type of data source. So in the case that I'm going to show you with Dynatrace, you specify a dashboard where you have your metrics on, and these are then the metrics that Captain will use to validate. So it's automating the analysis of metrics, and then it gives me a score back. So let me walk over. You've seen this earlier, right? This is kind of my quality gate from build number 4. Now, if I click on this dashboard link here, this is actually the dashboard that was used in the analysis. So it is as simple as putting metrics on a dashboard. I wanted to have response time, P95, P90, and P50. I also wanted to have some test transactions from my tests, and I also wanted to have some process metrics: CPU, memory, event loop tick count. My app is a Node.js app, so I just added these metrics. You can add any type of metric on it. All these metrics are then evaluated against the thresholds that you specify here, either static thresholds or absolute thresholds or relative. Relative means with the previous build. And really what Captain does, it is analyzing every single time I run a build. It's analyzing these metrics for me. It is scoring them for me, and then uses this for the evaluation, right? And as you can see here, my build number 4 from earlier was actually now deployed. I actually was rolled back again. Why? Because my build number 4 failed in production, because my build number 4 actually had an issue, so that was automatically rolled back because the evaluation after the production deployment failed again, because my failure rate increased dramatically, and therefore it was rolled back. So this is how all this concept works. One example also how you can integrate just quality gates with your existing delivery pipeline is what Christian is doing. They are also using GitLab. They're doing deployment testing, and in the verify stage, they then trigger a Captain evaluation where Captain is then collecting all the data, comparing the SLIs against the SLOs, and then telling GitLab whether this is a good or a bad build. And with this, automating an otherwise manual task. Now, third problem, a lot of time, once things are in production and there are problems in production, is spent in remediation. And we want to solve this also through an event-driven SRE-inspired approach. So what that means is, whatever monitoring tool you have that can send an alert, whether this is a Prometheus alert or a Dynatrace problem, any other tool that can send in a problem to Captain, Captain can then orchestrate a process for problem remediation. So similar what you saw earlier from me, where I specified the 3 stages in my delivery pipeline, here you can specify actions for remediation. So in this case, if there's a conversion rate drop coming in and the root cause is a CPU pressure, then my remediation workflow tells Captain first, trigger the scaling up of my system, but then very important, evaluate if that action actually had the desired impact by looking at the SLOs again. I also add a BLO, business level objectives, because you can also add any type of business metrics like conversion rates, user experience, and so on. If this doesn't solve the problem, you can define a next action. Again, reevaluate afterwards. If nothing of this solves the problem, then obviously we will escalate. Now, this is what we call closed loop remediation. And this is something that people really love, but some people are scared to start with this in production. This is why I believe the marriage of this approach with chaos engineering is a really cool thing. So we're working with Litmus and others out there. So if you have a safe environment or a test environment where you can run chaos experiments, the first thing is it validates your monitoring and alerting, but then you can use Captain to also define, test, and kind of strengthen your auto remediation scripts. So this is really a way to do test-driven auto remediation, because you want to make sure that if you enforce chaos in the environment, that your system is not only detecting it, but can also react to it. So in case this problem ever happens in production, you already know you have tested this remediation script. I think this is what we also want to propose here. I think this is a cool thing. All right, so to wrap it up, hopefully by now you know what Captain is. It's an event-driven control plane for continuous delivery and automated operations. We are separating the concerns of process definition, tooling definition. We're using cloud events as standard for communication. Therefore, it's very easy to integrate new tools or switch between tools, very easy. We are addressing these three problems and probably some more, but these are the three problems that I have shown you today about modern delivery, essentially saving a lot of time that is otherwise manually done. And if you are interested in more, go to tutorials.captain.sh where you can get started. Now I'm ready for Q&A. Hi there. Hopefully my talk gave you a couple of new ideas on what's possible with an event-driven approach to delivery. Now, I assume with Captain, we're not the only ones that are following that path, but hopefully we, give you some new ideas and an option in case you're looking into a new way of delivery. And yeah, if there are any questions, I will be very happy to take them. I know it's early in the morning for some of you, especially in the US on the West Coast. But for people like me, late in Europe, or at least mid-afternoon. Well, maybe I ask an ice-breaking question. Where are you from? Put it into the chat window. And I don't call you out. So just so that I see at least that somebody's there. India, hey. So the chat works. We just tested that. That's good. I do have a big testing back in Hong Kong. Very cool. Colorado. I am sitting here in Linz, Austria. So if you have any questions, I'm not sure if all of you had the chance to see the full presentation. So Captain is a CNCF sandbox project. Atlanta, welcome. And check us out on captain.sh is the website. On GitHub, you can find us on github.com/captain, and Captain is spelled KEPTN. We really believe that with the approach we took of doing an event-driven workflow, but giving you the chance to take individual workflows or individual parts, like just the quality gates, allows you to easily adapt parts of it. Around the content, we'll have questions later probably. Perfect. If you have questions later on, we also have a Slack. So we are both on the CNCF Slack. There's a Captain channel, but we also have our own Captain Slack. You can join it on slack.captain.sh. Where does the name come from? So Captain, spelled KEPTN, everything in Kubernetes, as you know, is Nordic, has Nordic terms, and Captain is a captain of a ship. Now, the way we spell it is the German phonetic version of a captain. So KEPTN, most of the contributors to that open source project come from the German-speaking region of Europe. And I guess, I think I'm still here, but somebody just left. So the name comes from, it's a German phonetic of captain. And the idea is nobody ships code like a captain. The captain brings you safely to the harbor, your destination, which should be production in a safe way. So this is where the name comes from. And I didn't come up with it. Somebody else came up with it, one of my team members. But I think it's actually pretty cool. KEPTN. What upcoming features on the Captain roadmap are you excited for? The upcoming features is a better separation of the control plane and the execution plane that I explained, which means right now, if you install Captain, all of the Captain services that are actually executing the tasks, they get installed in the same Kubernetes cluster as Captain because they latch on and subscribe to the Captain events in the same cluster. And therefore, really, if you want to do modifications within that cluster, if you want to deploy, you have to be installed in that same Kubernetes cluster. Now, what we're doing in upcoming versions is where we allow you to really separate the control plane from the execution plane, meaning you can install the different Captain services like the Helm deployment, Spinnaker integration, whatever you want, into other Kubernetes clusters. So that's one thing. The other thing that I'm excited about is the next version of the Shipyard. Shipyard, remember, that's the way how we define the process of what should happen in which stage, meaning what type of deployment, what type of testing, and what type of remediation. So it's really like right now a very opinionated way what happens within a stage. What we're doing in the next version of Shipyard is where we allow you to define your own set of actions and your own workflow within a stage. So you're no longer just like, constrained with our opinionated way, but you can say before deploy, you want to do something else. Between deploy and testing, you want to do something else. So you can really define your own process steps within what happens within a stage. I think that's also important. That's also stuff we learned from feedback. Another cool thing that is coming with 0.7.2, I believe that's when they're implementing it, is for the quality gates. Right now, as you have seen, quality gates, basically you pull data back. We pull data back from your SLI providers. But what if you had a bad deployment, a bad test? Right now, there's no way to invalidate quality gate results so that they should be ignored for the future because, again, maybe something bad happened in your environment. So this is coming. There's a Git issue that the team is already working on it where you can invalidate individual results, right? Which makes a lot of sense if you had a bad run and you don't want that to kind of mess up your heat map view or also impact the calculation of future quality gate runs. So that's also coming. There's also a lot of cool improvements, UI improvements coming into the bridge. These are kind of, I think, my highlights that I'm looking for. And then more and more integrations that people build. I know that somebody's currently building an SLI provider for Wavefront. We have people working on integrations from a testing perspective with Load Runner and I think Sauce Labs, if I'm not mistaken. So there's going to be more and more tools that are being integrated through a Captain service. Sam, curious, which tools do you use for chaos engineering other than Litmus? So we have the first Litmus integration already, I think, out there on the Captain community. We've also worked with Gremlin. So they have also shown and committed that they are going to build an integration with Captain, where the idea is that, as I explained in the presentation, Captain can then trigger a chaos experiment while your tests are running, while you're putting some load on the system. So these are the two primary tools we worked with so far. I'm sure there's more out there, but these are the two, Litmus and Gremlin. Yeah, thanks for all the questions now, right? Sometimes it takes a while until people warm up, but I don't bite. And even I wouldn't be able to bite you anyway because you're sitting somewhere completely different where I am. So, yeah, thanks, Jennifer, for that message. I think that's the end of my session. Thank you so much. If you want to follow up, please. I am a Borland software alumni. Yeah. I've been used to work for Segway, then Borland. Well, Segway got acquired by Borland, and I didn't make it through the Micro Focus acquisition. That's when I switched to Dynatrace about 12.5 years ago. Very cool. Well, I thank you, Manuel. Yeah, as I said, if you have any additional questions later on, I know you guys have to jump to the other sessions. You have my name. I'm sure you find me on Twitter, on LinkedIn. But from a captain perspective, there is a lot of material on the captain website, the captain Git repo, and the captain Slack. That would be great if you would join us there. Thanks, Nick. Sure. The Twitter handle is, and actually, let me just type it in. It's Grabner Andy. And LinkedIn should also be fairly easy. Let me just put that in as well. It's actually the same name. So it's this one here. I'm not sure if everybody sees the chat, but I believe so. So Grabner Andy with an I at the end, not with a Y. And then if you want to follow Captain, it is @CaptainProject, and it is slack.captain.sh. This is where you can, and I see you have a new follower. Look at that. Thank you. Technology, it's amazing. Connects people all around the world. You're welcome. Or bitteschön, as we say here in German. Yeah, I'm not sure how long before they kick us out. I see there's a lot of people are leaving anyway because you need to go to the next session. But yeah, for those that are still here, don't miss your next session. And thank you again.